Good afternoon, myself Varsha. We are giving demo on Cisco Packet Tracer.
Good afternoon, myself Divya. I'm going to explain Cisco Packet, how to install Cisco Packet Tracer. You have to download Cisco Packet Tracer from Google. It's a free of cost. We have to search for Cisco Packet Tracer student version 6.1. Now we have already downloaded the Cisco Packet Tracer. Now click on Cisco Packet Tracer. So, meanwhile, the Cisco packet getting installed, I will explain about the Cisco Packet Tracer. Cisco Packet Tracer is a utility that can be used by students to train themselves in CCNA and CCNP by permitting them to create network by utilizing unlimited number of devices. By using this application, you don't need to buy Cisco routers for experiencing troubleshooting. Cisco Packet Tracer 6.1 has different capabilities of visualization, authoring, and collaboration and provides facilities for learning some complicated technological concepts. The latest version of Cisco Packet Tracer is 6.1. The version has been released in student and instructor packages. There have been some new features introduced in Cisco Packet Tracer 6.1 and some of them are as follows. There is an introduction of new service tab. In previous versions, config and service tabs were gelled in one tab, but now service has its own tab. Some new server desktop applications like NetFlow Collector and AAA accounting have been included. IPv4 and IPv6, which in previous versions were parts of Service tab, have now been shifted as desktop application. As of I told about Cisco Packet Tracer, the important features of Cisco Packet Tracers are you can create networks by utilizing unlimited number of devices, can develop skills like decision making and critical thinking, and also a variety of new server application can also be done. Click on finish, and in Cisco Packet Tracer we can observe the behavior of data frames and packets as they traverse through routers, switches, and other devices. The kind of topologies required to build network are routers, repeaters, cloud, hub, switch, wireless access point, bridge, and TC. And also interface can be selected to interconnect hardware devices such as Ethernet, fast Ethernet, gigabit Ethernet, serial modem, wireless, and so on. Now this is called as menu toolbar, where you can create a new file and you can open an existing file. You can also save, print, and copy, and so on. And this is logical workspace where you will connect the devices, and this is device type selection box where you find routers. As we know, router is a more sophisticated device than either a switch or a hub, where router is a piece of network hardware that connects a local network to the internet. Most of the routers are more properly called as residential gateways. And we have hubs. Hubs forwards packets to the destinations, And we have switch. A network switch is a small network device that joins multiple computers together with one local area network. Network routers, switches and hubs are all common components of wired Ethernet networks. Routers forward network data more intelligently. Each feature has number of physical ports on the front or back of the unit that provides the connection points for these components. A connection for electric power and number of LED lights to display device status. And we have status bar where the connection device is connected, the status of the device is connected will be displayed. And we have common toolbar where you can send PDUs, means protocol data unit. And we also have two modes, real time mode and simulation mode. In real time mode, the connection of devices are displayed, and simulation mode, the execution of the connected devices will be shown, where you can ping the devices and see the status. And we'll explain the working of Cisco packet tracer by using a simple example, by connecting two devices with a router. This will be explained by Varsha.
Okay, let's go for an example for Cisco packet tracer. Now, we will create a small network with two end devices and one router. We will take two end devices, two generic devices, PC0 and PC1, which is connected to router 1841, which has given the connections through copper crossover connections. From PC0, it is through fast Ethernet 0 to router fast Ethernet 0/0. From PC1, copper crossover connection is given to router as fast Ethernet 0/1. Now click on router, go to CLI, there will be a configuration dialog box which asks yes or no. Type no, enter. Now type enable for entering the privilege exact mode. If we want to enter global configuration, type config T. Now we need the name of the router. So we will type hostname router 0. To set an encrypted password for privileged exact mode for a router, we will enable the secret class or an enable secret Cisco. Now we have to give the console line configuration by line con 0. Then give the password as Cisco, log into the password, then exit from the password login. Now type line VTY04 to configure for virtual terminal line. Then set the password. Then set the password for the virtual terminal line as Cisco. Log into it. then exit. To configure fast Ethernet interfaces, enter interface name as the fast Ethernet 0/0. Enter the IP address to set the interfaces IP address in subnet mask. IP address 192.168.1.1 space 255.255.0. For the later reference of the we need description for an interface. Description router 0 fast Ethernet 0/0. Enter, enter the command no shutdown to start the interface. Exit to callable interface. Repeat the configuration for the interface fast Ethernet 0/1. Fast Ethernet 0/1. Enter the IP address 192.168.2.1. Now enter the command no shutdown. Enter the command no shutdown to start the interface. Exit from the interface configuration mode and next exit for global configuration mode. Type show running config. Running dash config to display the current configuration which we have set. Now enter copy running dash config startup dash config to save this configuration to NVRAM. Write the copy of the running configuration. Now the configuration is built, so close the window of the router. The green dots represents that they are connected with the wires. Let's configure PCs. Click on PC 0, go to desktop icon, click on IP configuration, select the static, enter the IP address as 192.168.1.2. The subnet mask will be 255.255.255.0. The default gateway will be 192.168.1.1. Close the window of PC 0. Now click on PC 1. Go to desktop icon, click on IP configurations. It will be static. Now enter the IP address 192.168.12.2. Subnet mask will be 255.255.255.0. Now the default gateway will be 192.168.2.1. Close the window of PC1. Now let's strap PC0 to PC1. Click on PC0, go to desktop, select command prompt, write ping ipconfig to check the IP address of the PC0. It will display IP address, subnet mask and default gateway. Now write ping 192.168.2.2 to ping PC1. For the first time, it will show the request timeout. Try it once again. So now we are getting the replies and their statistics. Close the window. Let's see with the simulation mode now. Go to simulation mode, which is back of the real-time mode. Click on edit filters where the all checkboxes are punched. So you need to clear by clicking on show all none. Now go to edit filters where all checkboxes are empty. Click on ICMP, then click at the right hand side, click first yellow envelope which switches us to source and destination, that is from PC0 to PC1 through an PDU. PDU is a protocol data unit. Okay, now click on auto capture to begin the ping simulation. Now observe the PDU travels from PC0 to the router and router to PC1 and then back to PC0, which gives the acknowledgement. This is how we show that two devices are connected with a router. Now the packet is successfully accepted by PC0, which got acknowledged. In status box, it is successfully, the last status is successful, from source is PC0 and destination is PC1, which we are taking the protocol as ICMP. Here we are doing the events from which the packets are transferred from PC0 to the ICMP packets are transferred from PC0 to router, then router to PC1, which then sends an acknowledgement to the router to PC0. So the packet is successfully done. Thank you. Switches. First example was about the routers. In this example, we will take three end devices and one laptop device, which is connected to the switch. 3 switches. Okay, now we are going to take 3 generic PCs, PC0, PC1 and PC2, and one as laptop. Now take 3 switches which are 2960 as one switch in the middle of the 4 and one switch for the PC2 connection and another switch for the laptop connection. Now connect the PCs to the switches through copper straight wire. Now do the connection. Now do the connection with console wire to PC2 and switch 1. By using RS232 and console option. Same wise connect the console connections to PC0 and switch 0 as RS232 to console. Like that, connect the laptop 0 console connection to the switch 2 as a console. Now change the PC's IP address by clicking. Write the PC0 IP address as 192.168.1.1, which is PC0 IP address, whereas PC1 IP address is 192.168.1.2. Same wise do for PC2 and laptop as 192.168.1.3, and for the laptop the IP address would be 192.168.1.4. Now we are over with the IP address assignment. Now the green dots represents the connection with the wires. Now click on the PC0. Go to the desktop, IP configurations, write the IP as 192.1.1 and subnet mask will be 255.255.0. The default gateway will be 192.2.1. 1 for PC0. Now close the window of PC0. Same wise do for PC1, PC2 and PC3. Close the window of PC1. Now do for PC2. Close the window of PC 2. Now do for laptop. Close the window of the laptop. So there are connections got over. Now go to the simulation mode. Click on edit filters where all the checkboxes are punched. To empty the punched checkboxes, click on show all none. Then go to edit filter again, click on ICMP and DHCP, Internet Control Message Protocol, and DHCP is a dynamic host configuration protocol. Now assign the packets to PC2, PC0 to laptop. Then start auto capture or play. We will see the packets moving from IP address 192.168.1.1 to the switch 0. From there, we are moving the packet to 192.168.1.4. Then again, the laptop sends the acknowledgement to the switch 0, which get switch sends again acknowledgement to the PC 0. So the message is transmitted. Now if we filter again with other protocols except DHCP, we will take ARP, okay, address resolution protocol. Now address resolution protocol will send the 3 packets to PC1, 2 and PC3. Then again sends an acknowledgement to PC0. So we can observe here that the packets are moving from PC0 to PC1, 2 and 3 through a switch which is interconnected by four end devices. Now the packet is got acknowledged.